I will start with the video before the introduction. Yes, good morning, everyone. My name is Arkadiusz. You can call me Arek. I'm leading at ESRI business development and sales for the reality mapping capability. That is a part of the RGS reality and other tools. I will present it in a moment. Thank you for the invitation. And I like to start saying and setting the stage with the statistics from the Norwegian SINTEF. 90% of the data ever created was created in the last 2 years. So we are living in the data, in the ocean of data. We are being flooded with the data. And to manage this data, you need to have a good system. And you need to have a good strategy, how to absorb this data. Look on it from this perspective. There's more devices in this room than people. And those devices collect data, collect location, intelligence, and they are mapping you and us. And reality mapping, what we call the reality mapping, it's the process of creating accurate digital representation of the world. I like to explain this as the same way I explained this to my 7-year-old son. You were born with 2 eyes, and your eyes are like cameras, and your brain is a computing machine. You are mapping the reality around you every day in the real time in order to help you take decisions. You take hundreds of decisions during the day when you move on, and we are trying to replicate the same procedure that our brain is doing with our software. And how this is connected to the digital twin journey and digital twin story. We all are waiting for autonomous and self-driving cars. We all have been promised the predictive maintenance tools and so on. But before we reach the autonomous future, before we reach the predictive future, we have to agree on the reality. We have to describe it well. That means that we position the reality as a cornerstone, as a fundamental part of your digital twin journey. You cannot run simulation and scenario-based modeling before you map your reality with accurate data. If we reflect on the history of the GIS, for decades, it was all about the vector and raster data. All of you are working today with those data and building your system of records. We added 3D objects, LOD2 models, LOD3 models, in order to add the realism to your system of records. Today, we are adding the reality as the last and most realistic, comprehensive visual 3D background. It's not here to replace anything. It's only here to amplify your system of record. It's a new 3D photorealistic base map. RGS reality is able to produce point clouds, image match-based point clouds, DSM models, DTM models, true orthophotos. I will mention in a moment what the true orthophoto is, and the 3D mesh models. We have different applications for that, but we all call them under the reality mapping capability. They are depending on the type of the sensor you're using and the resolution of the imagery. And you may think, I've seen this, other companies do the same. And that's true, but only ESRI has a unique value proposition where we are able to consume all type of the imagery from satellite through the airborne sensors, drone sensors to your mobile devices. We can provide you with the cloud or on-prem enterprise storage. We have these applications to reproduce the reality, and then we are able to give you the applications to use it efficiently within one ecosystem, seamlessly, without need to shuffle data, without any additional handshakes. So that's the unique value proposition from us. If we look on it from the perspective of the value chain, I like to say that reality mapping is feeding GIS with the fresh content. So if you are working with the imagery or want to work with the imagery, look on the RGS reality as a bridge between the content, image content, and your 3D GIS, your geoportal, or extended reality. Seamlessly integrated with your system of record. First example and the first stop is an oriented image. Oriented image is an image that has a known position and orientation. If we display an oriented image in the split view with the 3D environment, we are able to use it for asset inspections. Or we can also use this for the video, use the oriented video, for example, for the defense or other thermal, for example, analysis of the roofs. The oriented images can be converted into orthophotos, or actually we call it true orthophotos. And here is a very big difference. 90% of mapping authorities and people today produce orthophotos. So they are rectifying the images on the terrain surface. That means that every object that is above the terrain surface might have a leaning effect. The leaning effect causes the occlusions. Occlusions are the parts of the images that you are not able to see. And if we are heading towards the automated AI-powered future, where we want to map automatically, you do not want to produce orthophotos, because your mapping will be offset with the leaning effect. So the true orthophoto is the very important product to be adopted for your purpose in the future if you want to introduce the automation. Here is an example of the DSM model and the true orthophoto model, and then overlaid GIS data. We have a perfect match between the true orthophoto and the GIS data. The last product of the reality mapping is the 3D reality mesh, so as we call it, mesh models. They are very geometrically accurate because they have been produced from the oriented imagery in the aerial triangulation process. They are watertight, that introduce a lot of potential for the analysis, and they are optimized for rapid streaming to display in the 3D geoportals. And we like to say, and we are proud of this, that we can operate at any scale. That's a second unique value proposition for our reality mapping, that there is no other company that has a software that can consume satellite, aerial, and drone imagery within one application. The top example is the Pleiades Airbus 30-centimeter mesh model from City of Sydney. The middle one is the Marlborough Castle, aerial imagery, 7.5 centimeter from Polish Mapping Authority. And the last one is the 2-centimeter drone imagery flown in the Port Coast by the Port Coast company in the Vietnamese port. Reality mapping and all the imagery at ESRI is cross-sector. You've seen the presentation how all our product portfolio is quite sector organized. And we like to say we are cutting through any silo, in any organization, in any sector. Because the reality mapping can support, operator. Reality mapping can be used for transportation to overlay, for example, point features, for defense to do the view sheet analysis, for urban planning to overlay the plans, or to project your spatial analysis data in a heat map. It gives you the new immersive background and puts your content into a correct context. And we have to talk about AI. Everybody talks about AI. We call it GeoAI. AI understands two things very well: language, that you all have experience with different chats, and image. And the same way that image can be classified and the standard image taken, we can classify images within ESRI tools. There is in ArcGIS Living Atlas, as for today, 83 pre-trained models that you can download and try on your data. Those are models that has been pre-trained on the standard data. I like to say this is a white Skoda that you have to take a little bit further to tailor to your data. You need to decide how you want to use it. Don't expect that it will work perfectly out of the box. You need to iterate on this model. But that model can help you automate, for example, building extraction. They can automate change detection. They can automate road extraction. It's all about here to help you shorten the time from the data and image capture to the product in as much possible automation. We are going to show at the Intergeo in 2 weeks new models with the automatic mapping for the buildings. So please stay tuned. And then if we look on it from the perspective what we can do with these products, the true orthophotos, DSM, and 3D mesh models from the cycle of your work. Some of you might work with the plan and design, analyze. Some of you are more interested with simulations. Other works with the maintenance and operations. And I have now a couple of the examples from the real projects and real customers showing you how they use this technology in everyday work. The first example is City of Oslo. The urban planning department combined the RGS reality with RGS urban and story maps to communicate with their citizens all the urban planning activity. They project different scenarios in the photorealistic background, publish this as a story map to have a transparent communication and transparent decision process with their citizens. Another example from, we are now in Vietnam, consulting company Port Coast has been hired to make a master plan for a new harbor. Vietnam is exporting a lot of the goods, as you know. And what they do, they fly with the drones and capture very photorealistic model of the existing industrial areas that will be renovated and rebuilt to the harbor area. So this is a 2-centimeter quality mesh model used as a reference for the planning purposes. City of Munich uses the reality mesh model in the transportation to visualize, for example, the traffic accidents. They took the statistical data, spatial-oriented data, statistically, with the position and number of the accidents, and plotted it as a heat map on top of the reality mesh model. We are able to perhaps see different reasons and understand why the accidents has happened. City of Duisburg uses the DSM models and the 3D mesh models to visualize the solar potential and calculate the possible return on investment per property to motivate people to invest into the solar panels. City of Stuttgart is using our AI technology to automatically map the trees. And here again, true orthophoto, so it's very important input data, because we are eliminating any leaning effect. We have a correct position for the tree, and we are able to estimate correct size of each of the tree. The trees can be also, here's an example from a different city where we use the true orthophoto to segment the tree and actually calculate and combine this with the point cloud, LiDAR point cloud, where the true orthophoto was used to segment the tree, create an outline of the tree. Point cloud was imported, laser point cloud. And then the trees are being segmented. So the point cloud is being classified based on the true orthophoto segmentation. This way we have the most accurate tree canopy size. And we are able to model it in a very realistic way. Back to Oslo. Urban planning department has run the airflow analysis and solar potential analysis just to prove to the citizens that the new development and building the new skyscrapers right in the middle of the city center will not affect poorly on their quality of life. Flood modeling. I mentioned that the meshes are watertight. That means that you are able to project the water flow, you are able to simulate the rainfall, and the water will distribute based on the mathematical and geometrical flow. We are able to import vector data from the geological, with the geological information about the structure of the soil. So apply different absorption on the sand and different on clay. That is, of course, depends on the water flow. In the utility example, oriented imagery and the mesh in the combination gives us a completely new insight. The user is able to, in the 3-dimensional, orient himself and then use the oriented imagery for the close zoom asset management and annotation. Utilities, underground. You all probably have seen this complex 2-dimensional, hard-to-read utility maps. If we are going to have a construction area and dig in this corner, how much better it is to convert this 2D utility map into the 3-dimensional model and set it in the 3-dimensional 3D mesh context. We are minimizing the risk of any accidents. That's an example from Poland. Using the real-time feeds. So we mentioned the Internet of Things. If the land forces would like to have any live information about the number of the people during the festival, how many pedestrians in what time at a certain area of the city, they are able to use our reality mesh model as a background and display the statistic information in the real time. The same information for the police or the bus positions, City of Boston, and this is a demo from the last year user conferences, where you are able in real time to visualize the position either from the buses or police or fire trucks within the very photorealistic background. Skanska in Norway, they are flying with the drones and doing the mesh almost every day and overlay the design model of the road in order to monitor if the subcontractors are building as planned. Costs of revoking the construction are huge, so they want to have almost daily progress and daily quality control before mistakes are made. And the city of Utrecht visualize all their road signs in the background of the 3D mesh, also other applications, and connected it with the system of records. So they are able to manage their road signs and see also connected with the mobile mapping data to see and inspect if the road sign needs to be replaced. So if you are looking towards the digital twin journey, there is 5 steps that you need to take. You need to start with the reality mapping. What level of the quality, what input data, it's up to you to decide. You need to connect your reality mapping with your existing system of records, so you can overlay your existing data with this reality mapping data. Look into our ArcGIS Living Atlas, where we are publishing a lot of open data. We have an open APIs to connect other open source data. Look into the connection with the real-time feed, so Internet of Things, and then, only then, once you take these 4 steps, start building your applications and solutions. This way you will build your digital twin journey. Thank you very much.